Back. So, organic chemistry. This is being recorded, as I say. Organic chemistry, chemistry of carbon, but not carbon dioxide or carbonates. Okay, these aren't regarded as organic things. All right. Now, organic chemistry is so large, this is such a large subject, that we split it up into parts. We split into smaller parts. And these smaller parts, as you probably know, are known as homologous series. Okay. Now, I'm not going to talk about all of the homologous series we do today, but the common ones, as you probably know from last year, are alkanes, alkenes, alcohols. Okay, and there's other ones. There's halogenoalkanes and stuff like that. And these are the groups of organic chemicals or groups of organic compounds. Groups of organic compounds. Okay, now they've all got what we call functional groups. Okay, and these functional groups are what makes them kind of exciting. Alkanes, there's no functional group in an alkane. Okay, alkene, the functional group is a double bond. Alcohol, a functional group is an OH group. And in a halogen alkane, the functional group is a halogen connected to a carbon. So let me go back to you guys. Are we all good so far? Do we get that? I've got to keep coming back to the same page and asking you, I'm afraid. So you'll have to answer quite quickly. Are we all good? Do we understand all that from first principles? Yeah, we're good. Helene is good. Lungi's good. Okay, Janet, you good? Excellent stuff. Excellent. All right, but we're not really talking about homologous series today. We won't really have time for that today. So what we're doing today is we're going to simply name things. Okay, so first of all, let's have a look at some alkanes. Okay. These are alkanes. And a nice simple alkane is ethane. Okay, this isn't the first alkane, this is the second alkane. Now there's ethane. Okay, now I'm going to take one of these hydrogens out. Go away, you silly thing. All right, and I'm going to put a chlorine here. Now I'm going to draw this again. I'm going to put the chlorine at the top here. Are these two compounds the same thing? You've got to answer that yourselves, guys. Are they the same compounds? If I've moved that around. Anyone want to answer? Be brave. Helene doesn't think so. Anyone else? All right, not to worry. We'll figure it out. Okay, these compounds, crazy but true, these are the same compounds. Okay, this is the same as, this equals this. Now, why is this? Let's draw these a bit nicer. There's a carbon. Now, as you know, these things look more like this, don't they? They're tetrahedral around the carbon atom, aren't they? So let's put that H there, that chlorine there, and the hydrogen there. Okay, so this is more representative of what this compound would look like. It's called chloroethane, by the way. Okay, this is more representative of what it looks like. And this bond in the middle, okay, I hope you know this, is known as a sigma bond. Okay, and the thing about sigma bonds, they allow rotation. So this thing can rotate. It rotates around this. So this molecule here can rotate into, let's redraw it here. It can rotate into this one. There's an H there, an H there, and a Cl here. So this can rotate. Because the bond in the middle is a sigma bond, we say it allows rotation. Okay, and because of that, this can rotate into this. So we regard these as the same. Okay, are we okay with that? That's quite a big point, actually. Yeah, no, they're not isomers, Janet. They're the same thing. Okay. Now they look like they're isomers, don't they? That's the whole point of what I'm trying to say. But they're not actually isomers. They're the same thing. Okay. Now this is a big deal. It means all the groups on this carbon. There's this carbon here. All the groups on here, each position, this position, this position, and this position, are known as equivalents. Okay, they're the same. All right. So if the chlorine is on this top one, this middle one, or this bottom one, it's the same. They're regarded as the same. If they're on the same carbon, the positions are the same. Okay. At the moment, things get a bit more complicated later. So that's worth knowing. Okay. We'll talk about that in a minute. All right. So I hope you get that, but those positions are equivalent. So now let's have a look at these two compounds. Let's go for 1, 2, 3. Okay. And 1, 2, 3. Now, are these compounds the same or not? Are these the same? Anyone want to answer that one? Are those two compounds the same? Janet says they're not. Anyone else have a guess? Anyone else? No, no one wants to go. Okay, fair enough. All right. Janet doesn't think they are, but they are the same. These are exactly the same. They're the same as each other. Now, why are they the same? Well, all we've done, if you think of it, if you treat it like this, Janet, this group here and this group here, okay, all we've done is we've changed that group, we've swapped it with this group. We've put the hydrogen there and we put this CH3 here, all right? And now the CH3 is on the bottom. But we haven't actually, we're looking at this carbon here, and all the groups on there are equivalent. Okay, so moving it down to the bottom there is exactly the same. Does that make sense? We haven't changed the compound. They're the same thing. They're both propane. Okay, right, so this one up here is called propane, and this one here is called propane. Now, you can think of it another way as well. You can think of it as, well, let's have a look at how many carbons there are in a row. And there's 3 carbons in a row here. But this one, there's also 3 in a row. All I've done is bent the thing. I haven't changed the structure of the molecule. They're the same thing. Okay, so these two are the same. Doesn't matter how I draw them like this. They're the same thing. They're both called propane. Are we reasonable about that? Are we reasonably okay with that? If you don't get it's why is this a thing? Why does this happen? What's the purpose of doing this to the molecules? Well, Helene, it's a good question. This is a thing, dear, because when you're given structures later, you have to identify, are they the same thing or are they different things? Okay. Now, don't forget, in organic chemistry and in all chemistry, these molecules get very long and they wriggle around like snakes. Yeah, they bend and do weird things. Yes. And they, as I say, they can present themselves in different ways. So you have to know these structures sort of backwards and forwards. You have to have a really good feel for these structures. Okay, so when they bend like this, you have to appreciate, is that the same thing or is that a different thing? Okay, I'd say about 60% of organic chemistry is understanding the shapes and where they come from. Does that make sense? Yeah, we'll talk about isomerism in a minute, Janet. Okay, so Helene's all right. This is not isomerism. Okay, so far they're the same thing. Okay, I know they look like different structures, but they're the same structure. If I have, let me think of a good example. If I have a pipe cleaner, I'm sure you've done this in biology. A pipe cleaner, one of these bits of metal with foam around them or whatever. If we have it in a straight line and we bend it, it's still the same thing. We've just bent it. All right. So all I'm doing at the moment is bending things. I'm not putting any isomerism stuff in there. Okay. We'll get to that in a minute. All right. So now, look, you're a bit shaky on these structures at the moment, but don't worry. All right, that's why we're doing these lessons, okay? Organic is a weird subject. It's a little bit different from the rest of chemistry, but it's beautiful. Trust me, it is nice. All right. Anyway, so don't worry too much about that, but we can bend things and they're still the same thing. That's all I want you to get from that at the moment. Okay, so let's have a look at some alkanes again. Alkanes. Let's have a look at some structures of alkanes. Well, alkanes have a general formula CN. Oh, no, let me get to that in a minute. Okay, alkanes. The first alkane is this. Okay, and the second alkane is this. All right, we'll talk about these in a minute, what these are called. And the third alkane, let me do it down here, is this. Now, these three alkanes, okay, these three alkanes, they're the only possible structures for these three alkanes. You can't get any other structures. There are no isomers for these structures. So let's have a look at them all. Well, the first one has a formula CH4. The second one has a formula C2H6, and the third one is C3H8. Okay, the first one has one carbon atom. We call this methane. Meth tells me there's one. Let me try and get a nice color here. This white color, I guess. Ane means it's an alkane. This one is going to be ane, and this last one down here is also going to be ane. Okay, let me get the blue back. This one is going to be called ethane, and this one down here, C3H8, is going to be called propane. Okay, so meth means one, eth means two, prop means three. Okay, and ane tells us the homologous group it belongs to, which is the alkanes. Well, the formula are CH4, C2H6, and C3H8. As you can see, I hope you can see that as we go from one to the next, from this one to this one, and from this one to this one, we're adding a CH2 unit. That's all we're adding. That's the difference between one member and the next member of a homologous series, just a CH2 unit. Now, these can be given what we call a general formula. And the general formula of these things is CnH2n plus 2. So far, are we good with that? We're taking it nice and slow because I think your organic is a bit rusty, to be honest with you. It seems a bit rusty. So Helene's good. So we've done meth, eth, and prop. That's all we've done. Okay, excellent stuff. We're good so far. All right, then now, they're the first three members. Let's have a look at the fourth member now. The fourth member is going to have 4 carbon atoms. Okay, so let's draw this one. Which color was I using? I think I was using that color. 1, 2, 3, 4. Okay, now I'm not going to draw the hydrogens yet. 1, 2, 3, 4, and 1, 2, 3, 4, and 1, 2, 3, 4. Okay, now talking about what we've just done, I've given you 4 structures here. Are they the same structure or are they not the same structure? Just say same or not. All right. Well done, Helene. They're the same. Can we all see that? Well done. They're the same structure. Okay. Well done. That's a good thing. You've done a good thing there. All right. How can we tell they're the same structure? Well, look, all I've done is it's 4 in a row. I may have bent it, but it's still 4 in a row. Okay. And all of these are the same. Now, I know you probably won't appreciate this yet, but what you've managed to do, you've managed to get this idea of this bond rotation. All that changes one structure into the other one is we've rotated bonds around. Okay, that's all I've done. I've rotated bonds around. Okay, so that's good. Well done. That's a very good thing. You've done a good thing. All right, I'm going to get rid of this rubbish. Don't forget we're filming this, so you can watch this later if you have a problem. All right, so let's do it again then. 1, 2, 3, 4, and let's put my hydrogens in. All right, now the first alkane with 4 carbons, believe it or not, we can do this. 1, 2, 3, 4. We can do this. Now, Janet's brought up this word a minute ago. There we go. Now I've put two structures here. Are these two structures the same thing? Same or not? Are those two structures the same? No one knows. Either that or my internet's gone, which could have been the case. Who knows? Do we see that they're the same or are they not the same? No one wants to say. Helene says the same. Are they the same? Janet and Lungi. Anyone know? Oh, come on, guys. Janet, Helene's at least had a guess. She thinks they're the same. All right, let's have a look at them. Now, let's draw the carbon backbone, 3 in a row. Carbon backbone here. It's not 3 in a row. Can we bend the top one? Is there any way we can bend the top one without breaking the chain? Can I bend the top one and make the bottom one? Is that possible? Can I bend the top one? Well done, Lungi and Janet, they're not the same. Can I bend the top one to make the bottom one? Is there any way, without breaking anything, can I bend it into the bottom one? Helene, can you, do you think? Is there any way you can bend it? Not break it, bend it. No, there's no way you can. Okay, now, oops, I missed that. Hold on, what did we see there? No, we can't. We can't do it. We can't bend one into the other one. Now, if you look at this one is 4 in a row. This is, we call this one a straight chain. This is known as a straight chain. And this one is a branched chain. There's branching. They're not the same. These two are not the same. You can see from the line of the carbon atoms, they're not the same. Okay, so they're not the same. All right, now let's have a look at the formula. Well, the top one has a formula of C4H8. And the bottom one, believe it or not, has the formula C4H8. So they've got the same formula there, but they're not the same structure, are they? Now, these are therefore known as, and I think Janet mentioned this before, these are called isomers. Okay, and that means the same molecular formula, but different structures. Okay, and that is what isomerism is. These are two isomers, and we say butane, this thing is called butane. We say butane has two isomers. Butane has two isomers. All right. Now, as a bonus point, the top one is called butane, as I've said there. Anyone know what the bottom one is called? Anyone know what we call this one? Anyone know? Have a guess at this one? It is a form of butane, but we don't call it butane. We call it something else. Anyone want to guess? Anyone fancy a guess? If you don't want to guess, say, I don't know, or IDK is fine. Okay, I want to move on. The thing is, all right, fair enough. Anyone else want to guess? Because that's what we're kind of going to look at in the next 10 minutes or so. All right, Helene doesn't know, which is fine. Okay, this one, well, it looks like, if you can imagine this, look at that. That is 3 in a row. So we call this one, believe it or not, we call it propane. Okay, now it's not propane, is it? Because this one is propane, but it looks a little bit like propane. So we call it propane, crazy, believe it or not. All right, but there's something on my propane. This thing here is on my propane. So we call this one, it's like there's a methyl. Methyl means a CH3 group. So that one's called methyl propane. Okay, there's a methyl group of CH3. Don't forget CH4 is methane, but CH3 is methyl. We'll get to that in a minute. So are we good with that? So butane has two isomers, butane and methyl propane. Are we all right with that? Do we get that? Do we get that now, Helene? Do you see that? It's a funny one. It's a bit of a weird one to do, I must admit. But never mind. There you go. All right. So let's have a look at some now. All right. Now, let's have a look at formula. Before we go on, let's have a look at formula. What does formula mean? All right. Well, it tells us the number and types of atoms in a molecule. That's what a formula is. Okay. These are, anyway, let me draw a nice molecule and you'll see what I mean. Let's draw 1, 2, 3, 4. Okay. Let's draw this thing. Okay, this is butane. There's no branching here, is there? This guy is called butane. Butane. 4 carbon atoms. Now, the first type of formula for butane is known as a molecular formula. Molecular formula. What is the molecular formula of butane? Well, it is simply C4H8. Okay, is that a useful formula for butane? Not really. It's not a really good formula because there's 2 isomers of butane. Okay, now this one, there's methyl propane and there's butane. There's two types of butane, and this doesn't help me at all. So in organic chemistry, we tend not to use molecular formula because they can be ambiguous. Okay, so we don't like molecular formula in organic. Okay, so after this one, molecular formula, we don't want it. This one here, the one I've drawn out here, this one is the best type of formula, and it's called a displayed formula. And it shows the structure beautifully. Now, displayed formula shows all bonds, and it's the best formula there is in chemistry. All right, displayed is great. Okay, now displayed formula is a type of structural formula because it shows structure. So if you're asked to draw a structural formula, you've got to do displayed. You can't do molecular. Okay, because a molecular formula is not a structural formula. A displayed formula is a structural formula. Do we all get that? Do we get that difference there? All right, I'm sorry to keep coming back to you, and I'm looking at the chat, and I just assume that if you don't say anything, I assume that everything's good. All right, Helen gets it. Good, excellent. All right. So, are there other types of formula? Well, unfortunately, there are. So this is the displayed formula here. Let's draw another type of formula. This is another type. CH3, CH2, CH2, CH3. Now, you might not like it, but this is also a structural formula. This is a structural, and this is molecular formula are not. This type of formula is known as a condensed formula. Now, it does show the structure. All right, it shows me there's a CH3 here, next to a CH2, next to another CH2, next to another CH3. These are condensed formula, and they're very useful as well. They show structure. Okay, so we don't like molecular formula. We like displayed. We like condensed. And the last type of formula is the one that students hate the most, and it's skeletal formula. But unfortunately, skeletal formula are very, very useful, but students don't like them. Okay, so all a skeletal formula does is it shows the backbone, the skeleton of the molecule. Now, listen to this. This is going to be strange. Let me pick a different color because this is a kind of a nice one. Okay, so the skeletal formula of butane is this: 1, 2, 3. Whoops. That's it. Okay, that's the skeletal formula of butane. All right, now what does all this mean? This bit at the end, that's a CH3. That one's also a CH3. This bit in the middle is the CH2, and that's the CH2. Okay, so that's butane. All right. Do you like? Who likes skeletal formula? Believe it or not, if you get into chemistry, they're the easiest to use. Believe it or not, they're quite nice. Anyway, so there's skeletal formula. Let's draw another skeletal formula for fun. All right, one. Where aren't you working? All right, let's pick nice yellow. 1, 2, 3, 4. What's that? The skeletal formula? Anyone? House points. Does anyone know what that's the skeletal formula for? Have a guess? Anyone? How many carbons are there? Not quite. Count how many. Yeah, it's hexane. Well done, Janet. I think it's hexane anyway. Let's count, shall we? 1. Oops, my pen's not working. 1. Why aren't you working? Some strange things going on with the thing. 1, 2, 3, 4, 5, 6. That's right. This is the skeletal formula for hexane. Well done, Janet. Let's have a look at another one, shall we? What's this the skeletal formula of? Anyone? That's a hard one. Try that one, but I won't give you long for that one. What's the skeletal formula? What's that one? It's not propane. It is a type of butane. Okay, well, that's good guesses. Well done. Right, remember 1, 2, 3. This is butane. And this one is 3 in a row. And a methyl attached to it. This is methyl propane. Do you remember that one? That one is the same as this one. All right. Now, look, I know it's confusing, this rubbish, but you will get the hang of it, I promise you. Okay? I promise you'll get the hang. It's not hard, really, at all. All right. So let's have a look at some other ones then. Let's have a look at this. Let me give you a nasty one, and let's try and name them. First of all, some rules. All right. If you have 1 carbon, or 2 carbons, or 3, 4, 5, 6, 7. Let's go up to 10, shall we? All right, 1 is meth. Let me do it in a different color. 1 is meth. 2 is eth. 3 is prop. 4 is but. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is non. And 10 is dec. All right. Now, these are the names we give to things. If you've got this thing here is an alkane, and it's called methane. But if you've got you haven't got the full thing, you've only got that, and if this adds to something, it's known as methyl. So methane is CH4, but methyl is CH3. Okay, this is an alkane, this top one. Okay, and this bottom one